We're going to look at transformations, and I've already put in all of these into the calculator. I've only got this one highlighted to look at, so this is what our basic function did. Now I want to see how this one changed. So I'm going to go back over here. I'm going to enter for my equals so it's dark. And when I do that, I'm going to graph it, and we'll see that it moved over and it shifted to the right. Now I don't want to have it too crowded, so I'm going to make sure that's not on, and I'm going to turn this one on. And let's see how it changed from our basic. So there's my original. Oh, this one flipped over the x-axis and it moved up one. And now, let's see what this other one looks like. If I look at this one and I graph it, again there's my basic. This one moved up and it moved to the right, and we're going to learn how to do those shifts. There are basically two types of transformation. There's a rigid transformation and a non-rigid transformation. Rigid, it's like the name implies, it doesn't change the size or the shape. What happens is it just moves it. So you can have vertical, up, down, you can have horizontal, so this one goes up, down, horizontal. And these would be reflections over the x or the y axis. Non-rigid means it distorts the shape. So you could have vertical stretch and shrink, you could have horizontal stretch and shrink. Alright, what we have here are these rigid transformations where we have vertical, horizontal reflections, non-rigid transformations where we have vertical and horizontal stretch and shrink. Now, vertical translation is a shift up or down. So if you see it written out where you have your function and you add a constant or you subtract a constant, it means it's going to the right, up and down, not right or left. So it's going up C or it's going down C units. When you see it inside of the function, then what that means is it's either going right or left. If it's x minus c, it's to the right. If it's x plus c, it's to the left. Alright, let's look at example 1. Here's my basic. This is outside of the basic function, so it went down 4. Here's the basic again. It's inside, so it went to the left too. Alright, in this next example, these are the pictures that we have. And we need to write, the red is my basic function. Now that is a cubic function. And it looks like I took this red one and I went down 3. Over here it looks like I took this red one and I went to the left 2. Over on this one, it looks like I took this one and I went to the right 3. So how would I change that in an equation form? Well, let's see. We had y equals 1 is my cubic. And what I did here is I went, let's see if we can see this. This one went down 3. So I'm going to write my basic as x cubed down 3. This one over here looks like I went to the left 2. To go to the left, I'm going to go plus 2 and then I cube it. Now this one over here looks like I went to the right 3. So it's inside it again, so it's to the right 3. And those are my new equations. Now these points here are reflections across the y or the x-axis. So let's see, if I draw it and I have x and y over here, and now I'm going to have the same x value but the opposite y, I reflected across this x-axis. So it's going to have this kind of format. If I have this and I draw the point xy, and now I have the same y value, but now here's my x and this is my negative x, I'm reflecting across the y-axis, and that means it's going to be inside. Now what I need to do is find an equation for the reflections. Here is the original one, and I want to cross each one, each axis. So let's see, if this is my original, to go across the x-axis, I want to look at f of negative x, which means I plug in a negative x in front. Okay, I'm going to look at the y-axis first, and I plug in a negative x, minus 9 over negative x squared plus 3. So now what I get is negative 5x minus 9 over x squared plus 3. That is a reflection across the y-axis. Now I need to do one across the x-axis, which means I want to get negative f of x. So I'm going to put a negative in front of my f of x. And then I'm going to verify this on the calculator. I carry my negative through. Now notice, they're not the exact same equation. So let's see what the graph looks like. Okay, I put the equation in. The first one is the original. This one is shifting across the y-axis, and this one is supposed to shift across the x-axis. So let's first graph the original. Here is the original. And if I'm looking at it shifting across the y-axis, that means everything here goes here and everything here goes here. So let's see if I highlight this one and I see if that's the case. And I'm going to make it a little bit, put a floating O so that you can see it. Now there is my reflection across the y-axis. And it does look like it flipped across the y-axis. So I got that equation correct. Now let's go back over here. I'm going to not highlight that one. Highlight this one. This one should now reflect across the x-axis. And let's see if it did that. There's my original. Across the x-axis means what's down gets flipped and what's up gets flipped down. And this is also correct. In this example, they're telling us that the even function doesn't look any different. So if I graphed an even function, let's say it's a y equals absolute value. Okay, and if I reflect it across the y-axis, it should look the same. So this is an example. We need to show this algebraically. So let's take a negative, and we're going to plug it in, and we're saying an even one should work. So let's take the example, f of x equals x squared. That's an even function. That graph looks like a parabola. So now I plug in a negative, and I plug in a negative, and I square it, and that's exactly what the original function is. That's why even functions do not look like any different when we reflect across the y-axis. Now what about horizontal stretches, shrinks? Those are a little bit different. And the reason that they're different is that the horizontals are, this would be a stretch. It's going to be the reciprocal. And if I put it, if C happens to be a number less than 1, it's going to be a shrink. Okay? So for an example, if I had f of x over 2, that's a stretch. If I have f of x over 1/2, that's a shrink. Now the verticals work just nicely. They work exactly what they said. If this is a bigger than 1, this is a stretch. And if this is less than 1, it is a shrink. And how is that going to work with this? Well, they tell us we want a vertical stretch by a factor of 3. So y2 is just going to be taking 3 times y1. 3 times x cubed minus 16x gives us 3x cubed minus 48x. Now you can also confirm this on the calculator. If you confirm it on the calculator, what ends up happening is you will see that it vertically stretched it. You might have to change your window a little bit though. Now this one tells us we want a horizontal shrink. So y3 is going to be whatever y1 is, but it's a horizontal shrink. So what I'm looking at is I'm going to take this and I'm going to shrink it by 1/2. So what I'm going to do is I'm going to take and simplify this, and that's what I'm putting into my equation. So now I'm going to take this, cube it, minus 16. So I'm going to take 2x and 2x, and now I get 8x cubed minus 32x. And that has shrunk this by a factor of 1/2. All right, now we're going to look at combining some transformation, and order is going to be important. So let's see, here's my basic. And we're going to go through these transformations in order, and we're going to find the equation. A horizontal shift of 2 units to the right. So I take this, and I'm going to shift 2 units to the right, and then square it. Then I'm going to stretch the whole thing by 3. And then I'm going to take the same function, and I'm going to move it up by 5. Now we got to try this in the opposite order and see if we get similar results or if we get a totally different equation. So I'm going to take this, and what I'm going to do is I'm going to have it go up 5. So it's x squared up 5. Then I'm going to take whatever this function is, and I'm going to stretch it by 3. And then what I'm going to do here is I'm going to now have a horizontal shift of 2 units to the right. Now these do not look anything alike. Notice this is 3 times 15. Now if you want to, you could expand these all out, and you would get 3 times x squared minus 4x plus 4 plus 5, and distribute, and you end up with 3x squared minus 12x plus 17. So that's what this ends up being. Let's see if the same one happens here. So now what I've got is I've got 3, and I'm going to expand this, 4x plus 4 plus 5. Now it's 3x squared minus 4x plus 9. And now I get 3x squared minus 12x plus 27. These are not the same, so the order is important. Okay, now this one takes a little bit of skill. What we're going to do is we are going to first stretch this by 2. Now that means all the y values get multiplied by 2. So this point here is the point -2, 0. Well, if I take y values and multiply 2 times 0, I'm still going to get 0. This one happens to be 2. Well, 2 times 2 is now 4. This one's a 0, so it stays. So this point here is 2, 2, and this here is 4, 0. And I'm multiplying all the y values by 2. 0 times 2, 0. 2 times 2, 4. 0 times 2, 0. So now I have vertically stretched this by 2. The next thing I need to do is I need to take every one of these points and shift it to the left 1. So I'm going to shift it to the left. Here's this one. Shift this one over to the left 1, and shift this one over to the left 1. So now this part of it looks like this. Now this part tells me I need to now take this and go down 3. So wherever my points are, I'm now going to go down 3. So let's see. I'm going to take wherever the 0 was, I'm now going to go down 3. And this one was at 4, 1, 2, 3. And this one goes down 3, 1, 2, 3. So now this thing looks like it's curvy, and then it's straight. And that is my final function. And that is the sequence of transformations. So we took this is my original, and we multiplied it by 2, the y values, and stretched it. Then we moved on the red to the right, the left 1, and then in the green we went down 3.